I think in the interest of time, let's go ahead and get started. Welcome everybody to session 2 of SEATRAC Art Intro workshops. My name is Shui Ma, and I'm a assistant professor at Seattle Children's and the SEATRAC Data Science Core co-lead. I'm just gonna kick-start today's session. As a reminder, the tutorial link to today's session is on the website link that I sent you guys. You can follow along through the tutorial link. There's also a cheat sheet that's associated with today's commands that should hopefully make things a little bit easier to work through. Here's the tutorial link. Today, it's my pleasure to introduce Dr. Ling Wei. She is a research scientist in Alexis Kashansky's lab here at Seattle Children's. She's a data science expert, and she's going to be telling us about how to wrangle spreadsheets with the tidyverse and how to plot things. So I think with that, I will let Ling take the floor and show us how to do things. Thanks, Ling.
Thank you, Shui, for the introduction. Hi, I'm Ling. So can everyone hear me and see my screen okay?
Yeah.
Great. Okay, so we will continue with our programming today, and we'll be working with spreadsheets, and then we will be practicing creating graphs in R. And then if we have time, I will introduce you to something very unique to R. That is a way of like coding in a different format, if we have time. Okay, so I hope everyone has showed up for the first session where we actually introduce how to install R Studio and then packages in R console. If not, I encourage everyone to install the tidyverse package for today's workshop, because we'll be heavily using 2 packages from this tidyverse package for today's workshop. So to install the packages in the command line in the console, you type install packages, then tidyverse. Okay, I'm not going to do it because it's already installed in my computer. So once it's installed, and then we will create a new file, RScript file, where we will start writing our code. Okay, so for manipulating data frames using R, it has a very huge advantage over Excel because it allows you to reproduce your operations on the data many times, and it also allows you to work with very large data sets that are it's more common thing right now with huge data sets generated every single day. There's a lot of advantages doing fancy coding in R that to work on your fancy data frames than Excel in general. So today I will be talking about one kind of package in a collection of packaging tidyverse, which is dplyr. So that package allows you to do a lot of data manipulations in R, and then follow that, I will introduce you a ggplot package, which will help you to create beautiful graphs for your study. So first of all, when you open the R script, this whatever package you have already installed will not be loaded automatically. So first thing you do, you want to load the package that you're going to use. So to do that, you type library. And then we just install, I hope everyone's installed this tidyverse package. So we will install that. We'll load that package. And then before we do things, to make things a lot easier, I want to make sure that we set up working directory properly so that we don't have to tap the full path to the files we want to access. with a lot of tapping. So to do that, you go to session and then set working directory and choose the directory where you want your files and your data files and your script to be stored at. So you can set. So I want my working directory to be in this directory. I open it. So we show up here. This is the folder I created for today's session. Okay. So I also hope that everyone has already downloaded this toy dataset that Shui has been using for her first session a couple of weeks ago. So that's a sample, a toy dataset from this heart disease dataset. So to load the data, we will be doing this that Shui has talked about last time. And then we will load our dataset. Heart disease. Okay. So once your data is loaded, it's showing up here in the environmental window where you can see roughly the structure of your data frame. And then if you click it, you can see a preview of your data since we only have 100 rows and then 22 columns shown here. So we basically can see everything of this data frame here. Also, if you don't want to actually click and see it in the preview setting, we can also check some specifications of this data that we just loaded. So one thing we can do is we can check the dimension of the data frame we load using dim, where it will tell you, okay, this data frame contains 100 rows and 22 columns. And then if you do spec data, it will show you the specifications of each individual columns in this data frame. So where we have 22 columns, and then we show you what the data type for each column. So for this specific data frame we have, so we have data types of character type, and we have numbers. Yeah. Now also, another way to view your data, like what we just did, clicking, we can use this view data to see the data. It's the same. If it's a lot easier for you, you can just simply click it on the window here. Okay, so we will start working on data columns first. Okay, so to start with, let's start with a very simple example. For instance, for our data frame now shown here, we have like each patient is on a different row and each column is a different measurement, right? So this is a unique layout for this specific data type. Sometimes the data will be flipped, like each patient will be on different rows and then each measurements will be on different column. Patient will be on different columns and measurements will be on different rows. And then you probably have to transpose them somehow to allow you to do what I will be talking about. But for today, I will assume that everyone's data set in this format and patient's information, individual patients will be on different rows here. So we'll start working with a simple example. If we want to select a single column from this data frame, it's very straightforward. You just use this function called select to do that selection. So for instance, if I want to have a single column extracted from this data frame, that I want this column to be a patient ID, which is our first column in the data frame, I will call the data, and then I will specify the column header of the column we want to extract. So for instance, I want to do the patient ID. So I will select the patient ID from this data frame. So we'll create a variable called data single column. And then if we click it, it will show us the column. It just subset from this data frame. It contains a full 100 rows of this data frame in the same order as original data frame. If we want to select multiple columns. It's easy because you just simply attach whatever column headers from after your first column you selected using the same function select. If I want to select BMI column, and then if I also want to select CRP level column, and make sure that when there's a space in your column names, you use a backticks to quote them. So it's not going to create any confusion. So here we extracted 3 columns from this data frame in the same order as the original data frame. You can sometimes rename your headers or data column headers because sometimes you're not happy with it because they have spaces or they're not very descriptive. So you have the option to rename your header names. To do that, we use a rename function. So for instance, if we want to rename the column age of this data frame, and then we will specify what the new name is. For instance, for the current data frame, this column age does not have a unit, and I know this is years, right? So I want to make it more descriptive, so I will put age year as a new name, and I want to rename this original column, which is age, right? So, and then we will have a new data frame where we replace the name as age year in this column, and then other columns will remain unchanged. Right. Is everyone still with me? Perfect. Yeah, so you can also modify your data frames, like you can add new columns to your data frame, and you can also delete columns. For instance, if I want to add a new column where I want this age year to be a new column with age in month. So to do that, you use this mutate function. Where I want to work on top of the data frame I just saved, which is renamed age column, that data frame. So I want to add a new column, which I want to call it age month. And then I want this column to be calculated from the age year column, because it's times 12, right? So I want to have a new column where I convert all the ages by a year to age in month. So this will, you can see that now we have an additional column here. So it's 23 columns right now in the data frame, where we have a new column attached to the very end of this data frame, where we have this values calculated from the age year column, but it does not look nice because we want this column to be right next to this age year. So we want to move columns around. So to do that, we can use this relocate function. To move columns around. So for instance, if I want to move this in this data frame that we just created, data at call, this one within this data frame, I want to move the column called age month after the age year column. So to do that, you use this dot after. You can, if you want to move it, for instance, if you want to do, we can either do it dot after age, or we can do it before gender, right? Either way. So I want to move it right after age month. So I will specify that here. Here we successfully moved this age month column right next to this age year column. Yeah, so there are a lot of other functions you can use to manipulate data columns. So if you're interested, there's a full description of this tidyverse packages on this website. There are tidyverse.org website. And then we use this dplyr. All the functions are part of this dplyr package where they have a very detailed description of each function. So we just used for column manipulations and as well as the row manipulations I'll be talking about in a minute. And they also have examples and they also have a beautiful cheat sheet here that you can navigate. Yeah, so now we switch to rows. So for the rows manipulation, the same as the column manipulation, you can specify your data rows by their index locations or by their values or even by some criteria that you set. So here I'm showing a few examples about row manipulation. So first we want to I want to show you how to select rows by criteria. So for instance, if we want to extract the data from patients that they smoke, and then I will have to use this filter function to filter out that the patients that they have the smoking habit column set yes. So to do that, save it to smoke, and then I will use this filter function on this data frame where I want to have this smoking to be true. Right. Smoking column, yes. So this, in this way, we will subset those data frame rows that contains all the patient information where they smoke. So we have 58 patients they smoke, and then they check all the smoking habit here, all yes. So we have 58 patients. And if you want to filter by multiple criteria, you can use this and or operations within this part of this argument. For instance, we want to subset the patient information where they smoke and they do not exercise. So we use the same function filter, and then it's going to be an AND operation, right? So we want them to be satisfy both criteria, smoking and also their exercise habit. Is low. So the key here is an AND operator. So here's a new variable we created, a subset of this data frame where the smoking is all yes, and then exercise habits are all low. So we have we can see from here that 24 patients that they meet this both criteria here. All right. And then in addition to use this filter function to subset your data frame by criteria, you can also subset your data frame by indices. So for instance, if I want to take out the data from the second through the fifth row, to do that, I use a slice function. On this data frame. And then if I want to take the data, as I said, to second through the fifth row, I can specify using this range format, where I specify the first row I want to start with, and then last row. So this way is inclusive. So we will include both the second row and the fifth row. So here we take out 4 rows from this original data frame. Do a sanity check. So the second one, 7572 through this. 2516, 5260. Yes, well, we got these 4 rows from the original data set. If everyone is still with me, I think we still have time. So I will go through some a little bit more advanced manipulations of data frames using this dplyr package. So we just talk about select the single rows or single columns or multiple columns, but in some cases where you want to select a range of columns. So that is the same concept as we're doing here using a range format. So for instance, if we want to select multiple columns between the patient ID column and this BMI column, we can do using the same select function on the data frame, but we specify the first column we want to keep, which is patient ID and then column and then BMI column. So by specifying this range, it will give us the entire subset of this data set between this patient ID and BMI column. Yeah. So here's where we subset a range of columns between this. Also, sometimes you want to take out all the data from the data frame except for specific columns, so you want to exclude. So instead, if I just want to exclude one single column, it does not make sense to write down the column names for the rest of the 21 columns to select them, right? So we want to simply exclude that single column. So to do that, we can use this the same function, but use explanation sign to specify that the column that we do not want. So the same function select, and we will specify using this sign that the column we do not want. So for instance, if we do not want this sleep hours column, we can do this, right? So we have 21 columns, and we do not have the sleep hours column anymore in this new data frame. Those are the bonus points for the column manipulation. And then we can also do some fancy stuff with the row selection as well. So we just talk about the specific rows we want to select. Sometimes you want to, like, a lot of people, they do statistics, they do like random modeling stuff, right? So in that case, you want to randomly select from your original big data set to just randomly select a subset of data to look at their distribution or something like that. So to do that, we use this slice function, but it's a different version of slice. So it's a slice sample function that we can use. For instance, if we want to take out a random 10 rows from this data frame where it contains 100 rows, right? So we can use this slash sample function on this data frame. We just need to specify the number of random rows we want to select from. So if we want to select 10 rows, we can do this. And it give us 10 randomly selected rows. So if you run this command one more time, it will give you a different set because every single time it's randomly selected from your seed. Yeah. Many times we in Excel, it's similar to Excel where we sort data by the values in that specific column or the entire data sheet, right? So here we can do the same thing using the R functions here. For instance, if we want to sort the data frame by the value of a specific column. For instance, if we want to sort this data frame by age, the patient age here, right? So we can simply use this arrange function in R. For instance, we can specify the column number you want to use for this sorting, right? So here I want to sort by age. Then you can see that it's already sorted, but by default it's ascending order, right? So if you do not specify you sort in the ascending order by default, if you want to change that, if you want to sort by descending order, you just need to specify here at helper function to tell the R that you want to sort it in a descending order. So if we do this, it's sorted in a descending order. Yeah, as I said, there are a lot of more functions that you could use or similar manipulations to what you usually do your daily life in Excel. But with R, it allows you to manipulate it in a higher level and then allows you to do your stuff in a more robust way and more reproducible way. If you have another data set that you want to work on next time, you don't have to like really work in Excel and then do a series of operations on those. So you can simply input that data into your already existing script and then run the program, and then we'll be like make sure that it's done properly. And then sometimes you have a huge data set that you really do not want to spend a minute to open that spreadsheet, where here you just need to get specifications of your data frame, the structure of your data frame, and then you can just apply your operations directly to in R without even opening that in Excel. Yeah, so in addition to this row and column manipulations, R can help you with all the statistics that you're interested in. So for this next session, we will talk about statistics in R. So it's very straightforward. The summarize function allows you to take out all the commonly seen statistics like average, mean, median, max, minimum, and also help you to calculate standard deviation variance of your data set. So you can do that in different ways. You can either calculate all together in the same row, or you can do them individually. So here I'll show you one example. So this summarize function, if we want to calculate the mean and median of this data frame on the BMI measurements. So I will use this summarize function, and then I will just specify what statistic I want to get out from this, right? So if I want to take a look at the BMI, mean value of this BMI, also I want to see the median value of this BMI column. I can do this, and it will print out in your console that will print out in your console where it's a mean value of this and median value of this. Same thing, if you want to look at this standard deviation and variance of your age, for instance, we can simply call this function and then standard deviation SD of the age column. And I also want to take a look at this variance of this column to see the spread of your data, right? So print out. You can also save them to a variable if you want. So here I'm not going to bother. Also, if you want to see the maximum and minimum values of the specific columns you're interested in, for instance, if I want to take a look at the max and minimum value of this CRP level, I can just call this min and max function and specify that. Make sure you have this backticks here because there's a space in the column name. So I want to look at this max of this column. Now arrange. Yeah. I'm showing here some common seeing statistics that you probably want to look at. But there are some other functions that I can take a look at. All the documentation is, so I'm going to share with you how to get help. So, so whatever function we have been talking about here, they are part of this dplyr package, right? And then this dplyr package is part of the tidyverse package collection that we installed or we loaded in the beginning of this session. So to get help, you can either navigate on their website to see examples and documentation of them, or you can do this in your R script, right? And then you just, if I want to look at this package R, I can call this function and then run it, and it will pop up on your window to the right, all the documentation and very nice examples for the functions I can use with this package. Also, if you are curious about specific functions, what argument, what they can do, you can just type in here in the search window the function you are interested in, and then you can just search, and then we have the examples and a detailed description of all the arguments that we can put within that function. Yeah. I think we're pretty much done with data manipulation. Using this dplyr package. If everyone is still with me, I'm going to move on with data visualization. Is that okay? Great, perfect. R is very good at making beautiful graphs. And then within R script, it allows you to modify the appearance of your graph, and then you can just adjust the font size and font type, and then the size of your figure, anything that you really, and then those plots generate from our publication level. So I will be introducing only two for this session, two very common seeing graph types. One is a scatter plot, the other is a box plot. So we will start with scatter plot here. So to create scatter plot in R, we use this ggplot package, which is also part of this tidyverse package. And then the detailed description of ggplot package is here. You can click and then navigate. There are a lot of interesting plots here, and you can do. And there's a use for R graphics cookbook that is electronic version is free, I think, that you can, if you're interested. They have the detailed description of how you create different types of graphs in R. This ggplot2 extensions have a lot of functions in addition to original ggplot package where people create fancy graphs. There are a lot of fancy graphs here you can navigate. So those are like additional resources that you can reach out to in case you're interested in making your plots in R. It's very slow, so I'm going to give up. So for ggplot2, the concept of ggplot2 graphs is they build up these graphs layer by layer. So it's not a one line of command. So usually the first step is to define your graph first, to define your X and Y axis. And then that's the first layer in general. And then the second layer is to tell R what format or geometry you want this graph to be, right? If you want to create a scatter plot, the geometry is apparently different from a box plot. And then additional layers can be added if you want to fine tune the appearance of this graph. For instance, if you want to adjust the XY labels, if you want to add titles, and or if you want to change the font size or colors or add like grid lines or something like that. So anything can be done layer by layer, right? So to start with, we'll create a simple scatter plot with the data we have in the data frame that we have been using. So I'm going to create a simple scatter plot where I want to plot fasting blood sugar against this CRP level in the scatter plot. Right. To do that, I call this ggplot function. The first layer, as I said, is to define a plot. So the data is from this data frame called data. And then I want to define the XY axis. So you just specify in this AES argument where you want your X and Y axis to be, right? So I want my X axis to be this fasting blood sugar column. And then I will tell R that I want my Y-axis to be this CRP level. And then what I mean by layer is like how you use this plus sign at the end of your layer, and then you add another layer. So then the second layer will be what the geometry of this plot. So I'm going to create a scatter plot. So I will specify the geometry using this geom point. So this will allow me to create a scatter plot based on the data from this X and Y axis as specified in the previous line. So this is a very simple, everything is going to be by default. So you create a plot like this, and will show to the right of your R Studio windows. So there are a lot of things we can do. For instance, I don't like this gray background. I want to change the background to be white and the gray lines to be black. So to do that, I add additional layer where I want to have this use a theme using a black-white background. So in this way, we will change the background to be something that's better, I hope. And then, so we have also have options to adjust the XY labels. So currently by default, because we're calling directly the data from this data frame, right? So, and then we specify the data from these two columns. So by default, these XY labels in the graph will be the column names that you use, right? So if I don't like this column, this XY labels, for instance, if I want to add units, which is required in many publications that you have to put your units to your XY plot. And then so in that way, I have to call this function labs to specify that I want to adjust the XY labels. Also, I want also to put the title to this plot as well. So everything will be done in this labs thing. So in labs, I will specify my new axis label. So I will be calling the same fasting blood sugar, but I'm going to add a unit to it. I do the same for y-axis. And this is the unit. So this will give us a different XY axis. And as I said, I want to put a title to this plot on top of this graph. So I just tell the title I want to put using this title argument. So
labels there instead of backticks?
What?
I'm wondering if the X argument to label should be quotes instead of backticks.
Oh yes, yeah, you're right. Yes. Yeah, because I'm renaming these columns. They're not original columns anymore. So I rename them in a double quote format, same as type. Thank you. Yeah. So now we have renamed this XY axis. And then we add a title here, but the title does not look good, right? It's not centered. I want it to be centered. So to do that, I want to add another layer where I want this title to be centered, and I want to increase the font size of this title. So to do that, I use this theme function, and within that, I want to I'm going to tell R that I'm going to work on the title. So plot title. So I'm going to work on the text, right? So I'm going to specify that I'm going to work on the text element here, and then I want to adjust this title to be centered. So to do that, you use this horizontal just and set it to be 0.5. So the reason I set it to be 0.5 is because this argument, if you set it's either 0.5 or 1, if it's 0, it will be by default aligned to the left, 1.0 will be aligned to the right, and then 0.5 will allow you to make it centered. So I will specify that. Also, I want to increase the size of this title to be slightly bigger. So give you a nice title. Yeah. So many times you want, when you plot your scatter plots, you want to see if there are any trend, right? So before that, I want to tell you something else. So you can also color code your individual data points in this plot, but that argument will happen in the first line where you define your plot here. So if I want to, we know that in this data frame, we have patients with different genders, right? If I want to color code their genders differently, so I will specify here color by gender. So it will give us two different groups, and then they were colored by gender. So it's a lot easier to see here, right? Yeah, so many times you have this scatter plot, you want to see the trends of your data, right? And many times you want to fit a linear line or some other higher order fitting. So for the scatter plot, usually we can do a linear model on top of this. We can see if the data from X, Y axis they actually correlate somehow. So to do that, you basically add one more layer here, where we use this function called geom_smooth. So this function allows you to add trend lines to your plot. So for this one, I will do a simple linear regression. I will put a linear line calculate between these two X, Y axis. So to do that, I will specify the method to be LM, linear models. It takes a while to calculate because they also calculate this confidence interval as you show here, because we separate this, we specify here we want to color code this data by gender. So we will have two groups of data here basically, and then the fitting will be done on individual groups. So you see two trend lines and then two gray areas, confidence intervals. You have the option to turn off this confidence intervals by setting this argument. SE argument is by default true, but you can turn off right. also this also by default, this confidence interval is 95%. You can, if you want to keep them on, you can set level to a different value, so that will display a different confidence interval, right? Here. Yeah. I think that's all about this scatter plot thing. So we talk about how to create a very basic scatter plot, or how to adjust the appearance of your scatter plot. And also we talk about how to add trend lines to your scatter plot. Additional functions, you can find them in the website of the ggplot2 website, where they have a lot of fancy arguments that I'm not showing you today. So if everyone is okay, I will move on to the next graph, box plot. So box plots, they're very helpful when you want to look at the distribution of your data and compare them across different groups, right? So here I want to use example of the triglyceride level, and I want to compare that measurement between people have or not have heart disease. So to start with, it's the same. We call this ggplot function. And then the first thing we do is we define the plot, define the axis. So I will specify our x-axis is a heart disease. So I want to put them into like on the x-axis, I will display on the left of people without a heart disease, and on the right is with heart disease, and then the y will be showing you this distribution of their triglyceride level. So that's how I want to lay out my graph. So I will define my axis, x to be heart disease status, and my y-axis be level. And then we want to be a box plot. So next line, we will specify the geometry of the plot using this box plot. Right. Yeah, it'll give us a very basic box plot from the data we just taken from the data frame. So we want to change the thing to be black and white, so that we don't have this gray background, right? So as you said, you can see here that we have this box plot, but we are now showing individual data points. So that can be done in R as well. So many times it's very helpful to actually show the individual data points in your graphs. So here we can call this a geom jitter function. So this function allows you to display your individual data points, as well as, because some data points, they're very close to each other, you don't want them to overlay on top of each other. So it also gives you a random noise generated to each data point on the horizontal axis, so that they have an offset, so you're able to clearly see individual data points, right? So on the x-axis, it gives you a random noise to make them more distributed, but on the y-axis, it maintains the original scale for the measurement triglyceride level for individual groups. You can also color code your groups. For instance, if I want to color code by if they have or do not have this heart disease, so I will specify here, same as we did for the scatter plot. Here we specify color by heart disease status. So it should give us different colors. So you can see that we have a box plot, but does not show you the error bars. And then if you want to put error bars on your plot, that also can be done. You can just call this stat box plot function, and then specify that you want to put this error bar. Also, you can specify how big you want the error bars to be as well in the same line. Got to put this plus sign. Now we have error bars. Yeah, I think this is all about the data visualization. There are definitely a lot more we can do, and then there are a lot of resources that we can use. Oh, it's loaded, great. So here on this website shows you all sorts of plots that created by ggplot. That if you have some idea about your data you want to visualize, you can refer to this website, and they have different functions. You can use different geometries that you can apply to your data. Yeah, be very helpful. Yeah, I think I'm done with data visualization part. Is anyone okay with me moving forward? Great. So I've finished everything that I'm supposed to talk about today. So right now we have plenty of time. I'm going to switch to the bonus session where I will be talking about pipes. Pipes are not very intuitive for many people, including me, because this is very unique way of writing your code. So conventionally, if you have multiple operations on your data, you usually nest them, right? So you have a nested parentheses operations, but that's not very straightforward, especially when you have too many nests. Many times you are missing one parenthesis where you have to spend many hours to debug. So pipes allows you to write your code in a way that each operation is chained in a linear way. So you write your operations individually and then pipe them. So it will allow you to clearly see what individual operations are and what the order of those operations, right? So it might not be very obvious from today's session because we're not going to build it up very, very complicated pipes. But it's just a concept of like maybe later on if you have very complicated operations on your data, and then you want to probably think about this using pipes to chain your manipulations. So if you remember, we have the first code we did for this session is where we select a single column from our data frame. We use this select function, and we specify, for instance, patient ID was the one we did. So this is how we write it down in a conventional format, right? So the pipes format is very interesting, where start with your data and then uses percent greater percent sign to chain your operations together. So this is just a one operation, but I'm going to write it down in a pipe format to get you used to this format. So to do that, we just call the function, but we do not call the data. We just specify the operation we want to do on this data. So if we want to select a patient ID, I just specify patient ID. It should give me a preview of this 10 patient. Actually, we are selecting the entire column, but it displays only the top 10 from the console. So it might be helpful in case you have multiple these pipes. So you can put them in a separate line if you want. Yeah. So if we want to select subset specific rows from the column we just selected. So it's additional layer of operation. So then we will add additional type operator here, and then we want to select slice out. I think what we did is row 2 to row 5. So we will call this slice function, and we will specify the rows we want to take out. So we're adding 2 operations here. So it will give us only 4 rows from the single column patient ID. So 4 values from this operation. So if this is a type way, right? It's very, very easy to get the point where you are doing 2 operations in a row. But if you write it down in a conventional format, that'd be nested, right? So what we did is we did a slice first. We did a selection of this column first, and then we sliced the rows. So in the conventional way, we write it, we have it nested in the last operation in almost order of this nesting, and then we slice from where we select patient ID. And we slice from this selection 2 to 5. Give us the same thing, right? But it's nested. I think from this, I'm hoping from this only 2 operations, you can get the point of why we have to, it's preferred to use this pipes operation when you have multiple nested operations here. Yeah, it's a lot easier to understand from this pipes operation, actually. Yeah, you can attach as many as operations you want using this pipe format. So for instance, if we want to calculate the statistics of people by gender, their BMI level. So it's kind of like very nested. As I described it, first of all, we want to group the people by gender. That's one operation. And then we want to take out the BMI values from each group. That's a second operation. And last operation is I want to calculate statistics of that. For instance, if I want to look at their mean values of BMI. So those are basically 3 operations. If we write it down in a pipes format, that'll be very straightforward. So from the data, first of all, we want to group by using this group by. So this group by function allows you to group your data by the criteria specified, but does not change your data frame. Just like all the calculations onwards will be based on this grouping, but will not change your data. So if we want to group by gender, that's our first operation. And then we chain up. And then I want to take out, select the BMI column from the data. So I will select the gender here and BMI. This is a second operation, right? And then the last operation I want to do is I want to look at the mean value of this BMI measurements for individual groups. So last one, as we just talked about, is a summarize function where I will call the mean value of this BMI. Yeah. So it will give you for individual, because it will group by gender, so it will give you 2 values for female and male groups, their average values of BMI measurement. Is everyone still with me? Perfect. I think that's it. That's all for today. I don't have any other bonus to show. Yeah. Let me know if you have any questions. questions online? We have prepared a cheat sheet, which is also uploaded to this GitHub website. It looks slightly different from what I'm doing today, but covers basically the same thing. But the order of the stuff I put here is different from what we actually went through. But it has a cheat sheet of all the commands we used for today's session. And as I said, there are a lot of resources out there, so you can use them. Yeah, for data manipulation and also for data visualization. Resource, you can refer to this ggplot and dplyr website, part of this tidyverse package website. Yeah. Should we close it? I didn't expect us to finish up early. Yeah. Of course. Yeah, let me know if you have any questions or we can finish this.
Will we be using these materials in the TD?
Sorry.
I just wonder if there's another session with actual TD activity.
Oh, I don't know. I'm not part of this SEATRAC thing. Sorry.
For the hack day, we'll be developing tools in R on a different data set. So we'll be using all this stuff, but we'll get more of a rundown on the day of for the actual data set and the specific goals from the team at UCSF.
Thank you, everyone. Have a great afternoon.